Suraj, are you ready? Yeah.
Okay,
Yes.
started recording. So this is the Mobile Science Lab project.
Our goal for this project is to design a mobile science lab that can transport experiments to rural schools for students that are in grades 4 through 10 in India in order to aid and supplement their hands-on learning experience overall.
So this is kind of where we're at this semester, and we'll talk more in a few slides about where we plan on going next semester. But the plan right now for the transportation of the experiments is to purchase an auto rickshaw, specifically the one you see in the picture here. Currently, with the situation, will not be buying it this semester or most likely next semester. However, that is the plan to eventually transport the experiments from school to school. We're also in the process of getting our experiments translated into Telugu. Currently, we have a team, so our partners sent out an email asking for assistance with translating, and they have about 25 NSS students who are getting NSS hours for doing this. And right as of now, I believe there are about 13 of our 50 experiments translated, and our partners said that they hope to have them all done by mid to end of February, which is awesome. And so now we are sort of moving into phase 2 of our project, which is looking at our experiment and seeing how we can incorporate technology and just continue to make it even better, and also potentially add virtual aspects given the COVID situation. And we had a call with our partners yesterday morning that was really interesting, and they brought up the idea of doing videos potentially, them doing videos as well as potentially us doing videos of doing the experiments, which I think would be a really cool virtual aspect given the situation. And we hope, our next slide, we'll talk more about the brainstorming of technology.
Yes, as Bree said, we are trying to find ways that we can enhance our project with technology. And so we started looking at how can we bring in microscopes, calculators, electronic scales, laptops, tablets, and projectors to our project without any limits. For example, for our microscopes, there are about 6 or 7 experiments that we have already made that could potentially use microscopes to make them even better. And also, if you look to our right, there is a storage case that we are planning to purchase for testing to see how we can fit the materials in for it, and also do a durability test. Next slide, please.
Yeah, so just to talk a little bit about some of our goals for this semester, we would like to create a CAD model of the storage and security system so that we can make sure all of our parts and pieces are going to fit together and kind of start moving forward with our implementation process in India. We would also like to test possible storage cases, which is going to tie in very closely to the CAD model because they're going to all work together and kind of evaluate the results from that, so we can figure out, what's going to be the most durable, what's going to last the longest, what's going to be least likely to break because we're not going to want to replace these things once we get them in place. And then we also want to review our current experiments that we have with some education students, because our team is made primarily of engineers. Actually, we're all engineers. So we know that there is a lot of room for us to learn from them and for us to improve. So we're hoping to review some of those things, and then we would also like to expand on some of our technology-focused experiments to kind of work that aspect into our project a little bit more.
Definitely, definitely. And if you remember from our last meeting, I was talking a little bit about some of the power designs and things that we could do for like a final year project, since I'm an electrical engineer. So right now we're actually forming a team of electrical engineers here at Purdue, as well as hopefully at IIT Tirupati. We're in communication with Dr. Rajan over there to hopefully get a combined team going that can be working on the power aspects of this project. But I think our overall goal is to kind of create a system where we can have multidisciplinary final year projects for this team. So hopefully we can create, a mechanical engineering final year project, civil, what have you. So hopefully we can put that in place to where any major can come in and hopefully do, several years here, and we can hopefully get more upperclassmen who will want to be doing this as like a final year project. We also have the potential for partnering with different organizations like IEEE, possibly. This is just purely theoretical right now, but I think it shows a little bit about what this project is going in the future and the connections that we want to make. So thank you. Does anyone have any questions for the Mobile Science Lab project?
So what's the duration of this project?
I'm sorry, can you repeat that?
Yeah, what will be the duration of this project? The slide you have just showed, final year project. The previous slides.
Yes.
So long-term goals and the final year project. So this final year project, what should be the duration?
So we're scoping the final year project for 1 year.
Okay, 1 year.
And as a pilot. And that's because Cody and his team, their final year project lasts a year, and at IIT Tripodi, they're also on a 1 year schedule. But that project would be within the larger project, which I honestly, the directions that this could go, we could keep students busy for years with supplementing and adding. The other thing that I would add is, one of the things that we struggle with is getting our because our EPICS program is not within a department. Is getting the departments to allow the students to do EPICS projects for final year. So if there's interest from IIT Delhi, like getting some mechanical students, we might, I can at least advance the discussion, and you've got some other pull with some influential people, but we're talking about mechanical engineering and that also. So we're looking to try to build these, but you know how it is. Okay. Yeah, you're familiar with your politics, and your institution, and they're similar here too.
Yeah. No, I think that's a very interesting proposition. I'm just thinking about the regulations. For example, if final year students of mechanical at IIT Delhi and few of your students from Purdue, when they work together in a project, and so you want them to, your students to defend to their department for their credits, and our students to defend our department for credits. How are you foreseeing that part?
So Cody would report to us and to meet our requirements, and the IIT students would be meeting their requirements. As they spec the project out, there are different ways to do this, and we're trying to identify the students and then the scope. But one way is one group of students is responsible for part of the system, the other group for another part, and then there's the expectation that there be an interface. But it's in trying to create this, you've got to make sure that one group can be successful if the other group is not, right? To be fair. Yeah, Cody's nodding. Yeah.
Yeah, no, that's very interesting. I experimented about 10 years ago with 2 different departments at IIT Delhi. And just to bring, for example, civil engineering students and mechanical engineering students working together for a common goal. And our civil engineering student defended to his department and mechanical. But later on, I saw that students themselves were not able to get much interest in doing together. I mean, we 2 professors kind of forced, or in a sense mobilized them. So otherwise, it's a very interesting concept. What we are doing today in RUTAC EPICS program is basically the same thing, but without the credit aspects of it, actually. So if we can bring the credit aspect, and in that context, one thing could be, even though we do not need any formal agreement, but if my department chair, if I can convince that let us officially float projects for our students which will be with Purdue, whether you call it EPICS or whatever. And once my department chair gives a consent to it, so it becomes kind of semi-official, and we can advertise to our students that these are the benefits in terms of interacting with international students. And maybe if you do a good job, maybe chance to do higher studies, that kind of things might attract them to come forward and solving internationally, group basically,
Yeah, I like that idea a lot. The logistics are a little bit confusing, but we're trying to figure that out now.
Yeah. Okay.
Any other questions about this?
I had keeping the current situation in mind, have you thought of any modifications? For example, like this might be out of the scope, but something like do-it-yourself videos where students can like make some experiments or do some experiments at their home, something like that.
Yeah, so that's what we were just talking about with our partners in our last week's call, is doing like these virtual videos that can potentially be like a kind of do-it-yourself instruction on how to actually do the project. So we're just starting that out now. So it's going to be a while before implemented, but hopefully with the help of our partners and the NSS, we can get some videos shot and then obviously translated. And yeah, hopefully we can be doing that in the future. So if there are no other questions about the Mobile Science Lab group, since we're actually still waiting on 2 members from the Bullet Driven Tractor team, Suraj, if you want to do one of your presentations in the meanwhile, if that'll be okay with you.
Yeah, sure. I think I'll start the presentation. So is my screen visible?
Yes.
So I'll be talking about this project called Bilwa seed decortication, which is ongoing. So Bilwa seeds, as you can see in the top right picture, these are called Bilwa fruits, and they are of commercial value, like they're used in preparation of traditional medicines. And when you de-seed this, the shell of this fruit, they give out some oil which is used to make dyes and tattoos. So these are the fruits, and on the bottom you can see are the seeds which are inside the fruits. So traditionally, these are the fruits are grown in central India, and in states like Madhya Pradesh and Maharashtra, tribal women. So they basically do this work of de-shelling. You can see in this video. So they catch this fruit in the hand and just hit it with a metal rod to break the shell, and the seeds are thrown in the basket nearby. You can observe the hands of her. She has tied sari or cloth, whatever she can find, so that the oil which splashes off the fruit, it does not touch her skin. So the oil is toxic and it causes boils or blisters on the skin. So these are manually extracted, the seeds, and they're sold. So this is we made a field visit to this place called Betul in Madhya Pradesh, and these are the 4 stages how it works. So initially, the fruits are dried in sunlight for around 2 to 3 weeks, and once it's dried and it becomes brittle, they break it with the metal rod as you've seen in the video, and these seeds are separated from the fruit. And the outer shells, they are then roasted in a kind of a furnace, not exactly a furnace, just a stove. And those seeds are then left like this on top of a tin, and the oil is collected, and then they sell these seeds as well as the oil. How it works, like the villagers, they purchase these food bags, which is of 56 kilos at 1,000 rupees. And out of this 56 kilos of food, they can extract approximately 7 kgs of seeds and 6 liters of oil. Then they sell it back to the middleman, who then sells it to market. So approximate profit is around 600 rupees to 1,000 rupees on each bag. RUTAG got this problem, and with the help of a private college, IAC in Greater Noida, the students, they came up with two solutions. One is a manual press, which is a small handheld device where they can just place the fruits, and just a mechanical press. If they pull down the lever with this slotted grill, the seeds come out, like the fruits get decorticated and the seeds get separated. A second concept was this a large scale motorage machine. The idea is to install this in the village cluster, and all the groups, the various groups which work on this, they can have a common facility or something like that where they can bring their seeds, and there's a toggle mechanism here. So it just de-shells the fruit, and then it can be collected and given up to the respective groups. So this work is in progress. This is my presentation. Thank you.
Is there any question, Suraj? Suraj, please check if there is any question from the audience.
Any questions? If not, then if the BDT team is ready, we can go with that. Or
we still are missing the design lead for Gang. So, like Anisha, if you never mind, he's here. I'm sorry. Okay, so yes, BDT team can present.
Sorry, we had overlapping classes with some of the students this morning. So
you start pretty early, Bill, no? 8 a.m. he said.
Yeah, Cody and Mergank have a class at 7:30 in the morning.
Oh, it's the best. Monday, Wednesday, Friday, 7:30. It's all right. So this is the bullet-driven tractor team.
Okay, so for our problem statement, as per usual, the design philosophy is the core part for taking in the rest of the considerations that we are going to apply for this semester. So our problem statement would be to create an ergonomic and cost-effective bullet-driven tractor that can efficiently lift farming attachments in order to aid rural farmers with the cultivation of crops. So if we go on to the next slide, we can see how we built upon this concept. So for our criteria for the bullet-driven tractor, it needs to be ergonomic, affordable, it needs to be easy to use and maintain, durable, has to be able to traverse multiple soil types, and needs the integrability of attachments. So for affordability, as many rural communities in India can't actually afford the full tractors, especially with the oil. There was an analysis that was done around the 2010 period showing when the oil prices peaked up, it could become unaffordable at points to consider to use a tractor. And as such, much of the industry has still relied for small-scale farming on use of animals. During the 2010 period, there was a large dip in oil prices, but it's coming back to normal, to be normalized, and possibly to be inflated, but it's better to not speculate. So between that, the diversification of the economy and an agrarian surplus, it becomes difficult for the Indian farmer to afford the mechanization in the sense of going for an oil-based machine. So with continuing to build upon the bullock-driven tractor concept, it would cost about 10,000 to 25,000 rupees to implement in the current design, or about 150 to 350 US dollars. It needs to be particularly ergonomic. So in our design, it has a very usable pulley, and it takes into consideration the comfortability of a rider throughout the full day of work. And for the bullock, it preserves energy of the bullock by weighing about 60 to 7 kilograms or 130 to 155 pounds. So throughout the day, it's not the most stressful piece of equipment for the bullock to actually be using. So as for integrability of attachments, it's able to lift about 35 kilograms to 30, or 66 to 77 pounds of weight. The plow in the back must be able to lift off the ground when turning. However, we can't use motored mechanisms to do this. We want to take as much stress off the farmer as possible to make it easy to lift attachments while driving the bullock. Traversal of multiple soil types is very important for this project, as we were particularly gearing this towards use in rice and wheat. So we want to make it usable in each type of soil environment, particularly in wet soils. So rice and wheat must be dug at different depths, and we have a stopper to change the attachment. For durability, we calculated about 5 to 10 years due to the durable materials in the lifespan calculated of the materials, particularly in chassis. And as for ease of use and maintenance, we're building it out of materials that can be easily found. And it's a simple mechanical build with a pulley operator, which should be plentifully available. So if any maintenance is needed, it will be a simple implement. So we create these criteria by benchmarking against different tractors in the market. And also we took into account the comfortability of the farmer by looking about a 6 to 8 hour workday with about a 1 to 2 hour rest period. And the lifespans that we calculated are industry standard based on the materials as previously said, particularly with the chassis. And we narrowed down the soil usage for rice and wheat. So we can go on to the next slide. So this is just a recap of some of the main points, and then on to the next slide. Design overview. So over here we see with the pulley design, with the chassis and the seat, which we may plan to change, which we do plan to look at, but our main phase of the design is currently moving on to implement of our CAD design in this semester, particularly with metalwork. So on to the next slide. As you can see, there's the adjustable seating based on the attachments applied. And on to the next slide. So close-up lifting mechanism.
Yeah. I guess talking about the mechanism specifically now, we've kind of displayed our CAD model. This is what you guys saw in our previous presentations. So this semester, we want to actually take this mechanism and convert it into a fully metal model. So this means that we'll be actually be able to test the seating, the tractor being able to be driven around, as well as being able to lift and lower the mechanism. While in the past, we'll go into a little bit more detail later in the presentation, we have made a wooden model that's allowed us to kind of see the motion of the mechanism up and down. We would like to actually make this full scale so we can actually see how it would practically function. So if you go to the next slide, Cody, again, this is something that we've kind of seen before. The stress simulation for our tractor is something that we performed, and I made sure to include the farmer weight, the implement weight, the material weight, as well as the added factor of safety. There will be other weights that will be added to this simulation to allow us to get a more accurate result as we finalize our parts throughout this prototyping process. So once we know exactly where the weight concentrations will be, we can definitely refine this model. But for now, we have assumed a flat weight of about 600 pounds, about 270 kilograms, distributed evenly on the surface frame of the tractor. And from our results, we found that we were getting a very promising results. We were getting almost no deflection in even the most vulnerable parts of the frame. You can see in the right image we have a deflection of about 0.27 millimeters. So it's we are very confident in this design, but again, once we actually make the physical prototype, we'll be able to test it to see if our results are consistent with a practical model. So next slide, please. So this is something something that this is a MATLAB model that we had created to essentially map out the amount of force that would be required to lift different different weight farming attachments, and allowed this to also vary with different mechanical advantages of levers that we'd be using. So you can see here the bottommost right, the one in blue, is for a mechanical advantage of about 1.5. This means that we would be able to essentially so with this mechanical advantage of 1.5, this means our lever arm has that mechanical advantage, and to lift 100 kilograms, we are only requiring about 64 kilograms of input force, which is very reasonable for to expect somebody to be able to push that much force with their foot. So again, we were very confident that this foot pedal will be comfortable to push, and it'll be feasible for us to push to be able to lift and lower a 100 kilogram attachment. We're making this, so far in this design process, we've been making the assumption that our main farming implements will be weighing about 60 to 70 kilograms. That's from some research papers we found, but we've had conversation with Suraj and Dr. Singh, so we'll be getting a exact weight that's currently implemented on the IIT tractor, so we can actually refine exactly where on this plow our specific tractor is, and exactly how much force would be required from the farmer. So this is kind of the this plot will be used in the future as we obviously improve our design and do the physical prototyping. So aside from that, I guess I'll pass on to Anisha to discuss this physical prototype that we created last semester and in this semester.
Okay, so you can see here is a second prototype that we built at the end of last semester, scaled model of the foot pedal and the pulley mechanism. And you can see that first we tried to use 3D printed parts, but they did not work well. So the pulleys also did not work well as much because the rope was definitely slipping. But we also see we could get a good motion of range. It was small, but we saw yet that it still worked. And from this, we decided to create a full-scale model that could be used to test the mechanism with the real load conditions. And with that, on the next slide, you can see the current design of the full-scale model of the pulley and the foot pedal mechanism. The model was created with wood studs, wall-mounted pulleys, wood screws, and rope. We created an Excel model to find the optimum dimensions that could give us the best mechanical advantage by this lever arm on the right, at the same time lift the attachment off the ground. For reference, by the lever arm is 53 centimeters, and the length of the arm ratio is 1 to 1.4. This would allow the farmer to lift 100 pounds of attachment weight with just 70 pounds of force. And with these dimensions, the attachment can be displaced 30 centimeters, and for reference, an ordinary plow rarely exceeds 20 centimeters. So for this, assume that the foot pedal will be pushed down at about 60 degrees from its rest position. You might have also noticed that there are two separate foot pedals. A design like this would allow the farmer to use either both foot pedals to lift the mechanism, or one while turning on the other side. Now, I'll pass it on to Miles to wrap it up.
Right. Yeah, like Anisha said, that this semester we're going to be working on building a full-scale prototype out of mild steel. So some of the specific parts that we would need are to buy are the steel for the steel base, an adjustable seat. Then we're going to machine parts for the lifting mechanism. And then we're also going to work on some of the safety guards. And if we pass it on to the next slide, I can tell us how we would do this. So this is the BIDC building, which just stands for the Bechtel Innovation Design Center. It's a workshop that we have on campus. And this is where we're going to be designing the full-scale prototype. And we talked with Suraj and Dr. Singh yesterday, I guess earlier this morning for them. And we talked about welding the steel because this would be very available and it would also be cheaper. So those are the methods that we're going to use as well. Next slide, please. So some of our current semester goals for Mrgank and Adrian, they're going to work on refining the CAD model, which is just updating it with the new, or there would just be refined dimensions of our full-scale model according to our calculations and simulations. They're also going to learn computer-aided manufacturing, and this will help with machining some of the more intricate parts that we have. We also are going to work on the lifting mechanism design, which basically creates like a position lock for the lever arm so that the plow can stay at a level position without moving. And then we're going to also continue to perform stress and strain simulations on Inventor. And then as for Anisha and I, we're going to find these parts and then order them in order to create the full-scale prototype. And then we're going to also do some testing. So we want to make sure that it can handle the load that we apply. We also want to identify any stress or failure points. So that's all we have. Is there any questions?
Yeah. So do you have the estimate of the cost of your prototype?
Anisha, I know you've been working on the budget. You want to take that question?
We have been currently this past week been researching different parts and finding it, but we hope by next week to have a good answer. But right now we're estimating maybe around 300 or 400 US dollars. The only thing that we don't know currently, that's the biggest one, is the price of the steel.
Okay. And maybe two slides before, previous two slides. Why do you have the physical prototype? Can you show me again? Yeah, this one. So when the implement is on the ground, touching the ground, how it will make sure that it is not lifting up? What is the locking device you have it here?
Right. So for this specific model, we were the whole purpose of building this model was to test if the mechanism moves up and down and if it's comfortable to lift. But we kind of mentioned this a little bit. But this semester, early this semester, me and Adrian will be actually working on building this locking mechanism that will go on the tractor. So like we're kind of working in parallel. So Anisha and Miles, they're working on building this frame that will be welded together, and then Adrian and I are going to be actually designing the stuff in CAD and doing the calculations to make sure that we can build this locking mechanism. So by the time that they are at the phase where they need to manufacture this locking mechanism, we should have that ready for them, and we can kind of work in parallel. If that makes sense.
Thank you. I think it's quite interesting development showing the stress strain simulations and physical. I'm quite impressed. Thank you.
Thank you.
Thank you very much. Okay,
Yeah,
so sorry.
Yeah, good morning, everyone. So nice work, BDT team. There's one suggestion that in your presentation and CAD model, I could see in morning, I just forgot to tell you guys that you also have to think that this bullock driven tractor is a, basically we have modified it in the form of tractor because we call it, that is why we call it bullock driven tractor. But in actual, a farmer walk holding a single plow, it's a very old technique. You could find it in YouTube. So the bullock driven tractor, we just added a wheel and farmer now sit. So this is from Regang. So you were asking for the weight of the plows or tines. But what happens that what we have observed during the field testing that you don't require that many number of plows to be attached in a one go while plowing the field, because usually what we have observed that if you add more than 2 or 3 plows, the force on bullocks increases. So usually if you could see, you just check it out on videos when farmer is using a conventional plow, which is actually a single plow only. So that much force is expected to be, bullock can handle. So in our bullock driven tractor, we just use 2 to 3 plows in a one go, not like 4 to 7 or 8 plows. So that will, help you in designing it further, because you were asking for the weight of a single plow, so that I will share it by Monday or Tuesday with you. So this was one of the things which I thought that you guys should also look into it. Thank you.
Right. So just kind of a comment on that. So for the IIT Delhi tractor, I believe that you guys had two plows implemented onto it. So so that we can reasonably assume that for our tractor it would also be two. That we
two
like more
or
like,
three. That
okay.
You will find it when you will use it when you manufacture a full-scale model. With tractor, while testing it with tractor, there were no issues. But when you test it with bullocks, there are certain issues by increasing the number of plows.
Yeah.
Okay, sounds good. Thank you.
Okay.
Yeah. Just out of curiosity, would you be able to get bullocks to test it in Purdue neighboring areas?
Not that I know of.
Okay. So you have to ship to India then.
Well, I maybe not likely, but it's possible. So
No,
we can. The
yeah.
Purdue University has farms. We might be able to do that.
Yeah.
I have friends that are farmers.
Okay.
We'll have to look.
Yeah.
At that.
But
It's possible. If you had to say yes or no, I'd say no at this point, but it is possible.
Okay.
We're going to explore it.
Yeah, you may try, because before we took it to the field, we used the tractor to the pull the vehicle. Wasn't it, Devinder? You did it with the tractor itself.
Yes, exactly, sir. Exactly.
Yeah. Okay.
Okay, so I think we finished from the Purdue side, right?
Yes, that was all of our presentations.
Okay, so we have two more from our side. I think we'll go with Tree Climber first, and then Tawa making process.
Devinder, we're waiting for you.
Hello.
Yes, sir.
Hello. I'm sorry. Yeah, there is some issue with my current laptop. So can you guys see my screen?
Yes.
Yes.
So, sorry, actually there is some issue with my computer. So, is it full screen now?
Yes.
Yes. Now.
So hope you guys can hear me. So, good morning, everyone. Today we will be talking about a very new project. Just Suraj has told you that Bilwa seed decorticator. Similarly, today I am going to show you a new project, which is Coconut Tree Climber, which we are actually helping out one of the NGOs in Kerala, the south of India. So you must have seen lots and lot of tree climbers, and there is I mean, if you go to south of India, you will find, or a coastal area, you will find lot of coconut trees, and every 45 days to 60 days, people have to harvest this coconut. So traditionally, they are done by, usually there is a person, he is a very well trained person who don't use any harnesses, and they are very fast, and they get a very small amount of money to harvest these coconut from tree climbers, and you will find lot of people using it. So, but there is a stigma of safety, and there are, what we have heard, there are every season there are few deaths related to this tree climber. Though these artisans, or you can say these farmers or these laborers, they earn, I mean, comparatively good money, but the stigma is that nobody nobody wants to get married to them because of this profession, and because of death associated with it. There are risks, and then sometimes they fell, and then there is not even death, but it's like they get paralyzed and so on. So there are many models. So we thought that let's find out, let's explore what are the flaws in its existing models, and let's try to improvise that. So IIT came up with this model. This we replicated from one of the Swiss model, which is existing in many parts of the world. It is very safe, and but it was a bit expensive. When we tried to order it, it was coming at around $3,000 to $5,000 each. So what we thought that let's make a prototype. What the picture you are seeing is a prototype we made using MS Steel, which was pretty bit heavier version, but we find it, let's try it. And because since we are getting that particular model for a very higher price, so let's make it in IIT itself. So we were able to develop it under I guess 8,000 rupees or so on. So we thought that let's try this model in the field, and so we went to Kerala with help of Dr. Susha. She's a postdoc student with Professor Saha. She arranged all the help of the NGOs and so on. So when we went there, we gave a demonstration over there to this particular NGO. So what we found that we were finding it very difficult to that one leg of the tree climber was not working well. So we thought that we could improvise. I'm so sorry, that video is not working. I think my computer is still. I'm still facing problem with my computer. So anyway, I will show you the video later. So this is how they were. The existing tree climber was there with them. They were not wearing any harnesses, and they just have to hold this, and with the help of foot and with this some kind of leverages, they have to keep going up till the top of the tree, and then they harvest this coconut. So the moment we gave them harness, this lady who was actually doing it from a very long time, she was so happy to wear it, and she could use her own device without any fear, without any getting scared, because these trees are pretty high. You all must have seen in pictures and so on. They are around 30 feet or something, 40 feet high. Maybe some trees might be more than that. So then we gave our model to try it. So there was some, they were finding it, though they find it very comfortable and very robust, and it really, with this model, they could feel the sense of safety, which was our priority at that time. So on, then we came back and started analyzing kinematics, force analysis, and so on, that where the things are getting wrong. And this is an ongoing project, very interesting project, which is still going on. And we are thinking of making changes in the design which we fabricated, and all those analyses are in progress. So this was all about tree climber. Thank you, guys.
Thank you. Any questions for them?
Not a question, but I was thinking to appeal to the EPICS groups. Maybe if they would like to take these as one of their future projects. It will be nice to compare their design and our design.
Yeah, I mean, I liked this project a lot. I think it was really interesting. I think this was the first time that we've seen this in the World-R, if I'm not mistaken.
Sure.
Professor Oakes, how feasible would it be to potentially, advise or take on another project?
It's just finding the enough students and the right students. So
Yeah, right now we only have 11 students on our team.
Yeah.
So I guess in previous semesters we've had upwards of like 15, 16. So I guess if that were to be the case in recent
and it would be
semester.
right. So looking at this project, we don't have the bandwidth this semester, but we could look at recruiting students for the next semester.
Sure, no problem.
Yeah. No, I think it's an interesting project. What? Yeah, let's talk more, because that may have the kind of sophistication that we could recruit some older students.
Yeah, I like this a lot.
Yeah, no, you know, in Thailand, they train monkeys actually to harvest coconut.
Wow.
And in India, there were attempts to train monkeys, but our government bodies tried with agencies. They could not succeed. Either they are not so smart, or they may be not understand the language of Thai. So there are robotized devices, but they become so expensive actually. Many of the poor farmers would not like to use it. So I think this mechanism, if we can come up, it would be really, innovative one actually. Yeah.
Yeah, I immediately thought of like a deer blind, like what hunters use to get up in trees. Like that's at least what my mind went to.
Yeah. Yeah, Suraj, I'm done.
Okay, and then we'll move on to the final presentation, Tawa making project.
Vipul and Harshit, are you ready?
Yes, sir. Sure.
Okay, so Vipul will start, right? I'll share your presentation, okay?
Harshit will start, sir.
Harshit will start? Okay,
Yes,
fine,
sir.
fine. Okay, so can you see my screen?
Yeah.
Okay, you can go ahead.
Okay, so yeah. Hello guys, hello everyone. So yeah, our project is a computer simulation of earth and tawa making process in Poonchali village and its improvement. So next slide, please. Okay, so the background of this project: pottery sector in the village of Poonchali is seeing a steady decline in growth and productivity. So Poonchali is a village in Rajasthan. It's a fairly backward village, and pottery making is the main livelihood of so many people there. So they usually mainly make this earthen tawas using primitive techniques, and not many large scale industries have overtaken them in the business. So the people in this village have seen a steady decline in the profits and the margins. So, they cannot afford to upgrade these techniques of making tawas, since they are not since they are fairly backward and poor. The main issue here is the firing process, which is quite inefficient, and also huge amounts of loss due to the breakage of tawas during the production process. So next slide, please. So yeah, in this set of images, we can see the process of molding tawas into the process of making tawas before baking them. The material they are using is clay soil mixed with some other catalyst. Okay, so can we move to next slide? So the principal objective of our project is to simulate a tawa making process using ANSYS Fluent and solving some equations in MATLAB and suggesting some improvements in the firing process. Next slide, please. So this is. Yeah, we good. Hello.
Okay, so this is the field where firing process took place. So in general, there were 8 layers in this circular in shape. So the first was ground. Over that, mustard husk was used as a fuel, and it was placed. Then second fuel was the dried dung cakes. Then again they used mustard husk, and then the tawa, which was our load. Then the same fuel was again put over the tawa layer. Next slide, please. So these are some pictures of the setup. Here we have used Type K thermocouple, which we developed in our mechanical engineering lab in IIT Delhi itself. So this was our setup. Next slide. So these are the stacked layers of fuel and the load. 75% of the total dung cakes were used in the second layer itself. So like the fifth layer was slightly lesser than the second one. Next slide. So we placed 6 thermocouples on the left and the right side of the center at a 1 feet distance on various positions of the tawa, like on the top, middle and bottom, and like 2 thermocouples were placed 4 feet from the center at towards the periphery to measure the temperature profile of the firing process. Next slide. Later on, after the field visit, we calculated the efficiency of the current process using the data we collected. So the present frequency efficiency of the current process is 7.98. Next slide.
So I'll take on from here. So for our preliminary analysis, we have just we tried to replicate we tried to simplify the model and model the whole setup in this sort of linear fashion. What you have seen in the previous slides, that circular arrangement have been changed to this linear pattern. And all these layers you can see, we just taken this for the ease of calculation in the preliminary model. Next slide, please. So yeah, we have taken a transient conduction analysis on this. This is a fairly basic two-dimensional transient conduction equation. And next slide, please. Yeah, we have okay. So as you can see here, we have written equations for all the different layers individually. The important term here, which you have to focus, is the last term, which Q.5 and Q.6. These are the energy generation terms which we have calculated by assuming a constant velocity of the flame front. Next slide, please. Yeah, these are the equations for first, second, and third layers. Next slide. So the further steps which we have to do is we have to solve these equations using a MATLAB and compare them with the actual data which you have got from the site and proceed from there. People will to take over. Yeah.
So that is all we have done till now. So we plan to use finite element method to get a solution and the temperature analyze temperature profile for the whole process, then compare it to the actually collected data. So thank you. That will be all. Any questions?
Thank you. You could have added a slide explaining what tawa is. Might not know.
Right. So yeah, I'll give some clarity on this. Tawa is basically what you make chapatis or flatbreads on. These are fairly like a you can
pan.
think them
it's
as
like a pan, right?
Yeah, it's like a pan. Yeah, it's like a pan made of clay. Simply.
Yeah, any questions for the team?
I just wanted to check, is this your BTech project, final year projects, or it's just you're doing it as
Yes,
a
sir,
part?
it's a BTP. It's a BTP.
BTP. Is it part 1 is complete?
Yes, sir.
So you are continuing with part 2?
No, sir, not actually.
So is anybody taking forward this project?
Yes, sir, Yashwant Prasad sir will be taking forward.
Okay. Any question from Pardue side? Yeah, Epic side, no?
I don't have any questions. Just wanted to say great presentation. That really explained a lot. So thank you.
Okay, so I think we are done with all the presentations for today. Sasha, if you have any words.
No, I think thanks to both the teams here, and I think it's nice to see the progresses made by the team, and I think things are getting improved in a sense. I see a lot of analysis getting into the design steps from the both sides, and I think which is very positive because the social problems we are solving, which are getting fundamental approaches to make them possibly more efficient and more, economic actually, and I use the phrase researchizing rural problems, How do you create research items from the rural problems? So thanks for both the teams. And before we decide the next date, maybe Bill or Cody can say something, and then we can decide the date.
Yeah, I want to thank both teams. I've appreciated the reaction, the interaction, and I know our students have found it helpful and valuable, and I think it's a wonderful model. The things you're doing too, there's so many needs within the communities, and the focus on the rural areas in both India and United States are areas that are often forgotten, and there are a lot of opportunities. And I'll echo the sophistication. I think we've really increased the sophistication of the designs for that, and we appreciate the growing relationships that we have. And my final thought, it's pretty extraordinary. I am in a lot of meetings where people are making excuses with the COVID and the reason that progress hasn't been made. And I think it's commendable to our students that they've really advanced the relationships during this time. So I appreciate that. I really enjoy our Purdue students. They're a great group, and the opportunity to interact with another outstanding group over there, it is wonderful. Thank you.
Yes, thank you again to everyone. This was a really helpful meeting, and I look forward to doing it again in the future. So Professor Saha, I'll be sure to email you when we plan on doing this again. So certainly by the end of this semester.
So when your semester is going to end?
The first week of May. So
do we want to target? Do we want to look at?
Yeah. So I'm looking at my calendar here actually. So I was thinking if the semester ends in May, so maybe April, first week, second week, tentative dates, we can probably keep it, and we may change based on the need. So I may propose maybe April. Let's see.
When is our Pooja? When is the final design review?
So I'm looking at the
April
calendar,
23rd.
and final
24. Yeah, 23rd. My bad. 23rd.
23rd. What about the 9th? April 9th?
That's what I was looking at.
Yeah, that sounds good.
Okay.
Same time?
Okay. Yeah.
Yeah.
Okay.
That fits in our schedule.
Daylight savings time will be by then.
Yeah.
So that'll be if we're doing the same
Therefore.
time for you guys, that would be 9 a.m. for us. I just want to
Okay.
remind
It's
everyone.
better for you. That's better for you, right?
I like that better.
Yeah. No, we could do that. We'd be limited to 1 hour and 20 minutes, but I think judging by today, that will be fine.
Yeah. Okay. So I think that's a good day for us also. In case there are certain other work, then we may always change over the email. And okay. before we leave, Bill and Cody, maybe the final year project arrangements with our departments and chair, maybe we can explore how it can be taken further, which will further strengthen our relationship.
Yeah, I'll follow up with you on some ideas that I think it would be. Yeah, let's follow up because maybe we could find something in mechanical or look at a discipline and then we can look.
Yeah.
But adding that, I'll need to find the students. But if we have an idea that we can try to recruit, so I'd be happy to do that.
Yeah. Okay.
Excellent.
So thank you everybody. Bye.
Yes, thank you all so much. Thank you.
Yeah, bye. Bye everyone.
Thank you. Thank you. Have a great day.
You guys too.
Can we have the